Hi everyone, our webinar will begin in just a minute as people are still joining. Thank you for your patience. Our webinar will begin in 1 minute. Before we begin, I want to let everyone know that there is a chat/question function for this webinar. If you have anything that you would like to ask participants, please put it in that field. Thank you. John, take it away.
Well, hello everyone. I'm John Kelly. I'm past president of the American Nuclear Society and former chief technology officer at the U.S. Department of Energy, now retired. I will be co-moderating this session with Julia Visconti, who's a senior advisor for multilateral cooperation in the U.S. Department of Energy Office of Nuclear Energy. And welcome to our speakers and panelists and all the participants. We have more than 100 registrants from around the world for this webinar. And today's webinar is being recorded and will be available for rebroadcast replay on Saturday, November 7 at 12 p.m. Eastern Standard Time. And it will be also available in the future at your convenience. Please tell your colleagues about this webinar so that they may see what the information that we're providing today. And I want to say special thanks to the Idaho National Laboratory staff for hosting the webinar and providing the technical assistance. Our first webinar in July focused on recent initiatives in the United States. These efforts included what was happening in the American Nuclear Society, Idaho National Lab, and at DOE. We also had speakers from the IAEA who provided their global outreach perspectives, and from DOE who discussed the International Clean Energy Education and Empowerment Initiative, C3E, which is a gender diversity initiative of the Clean Energy Ministerial. The replay link for that webinar is on the NICE Future website, which is www.nice-future.org. Today's webinar is a second in the series, and in the Inform and Inspire Next Generation, and highlights educational K through 12, and in the U.S., K through 12 means kindergarten through 12th grade, perspectives and initiatives from international professionals and U.S. Department of Energy national laboratories. Collectively, we intend this webinar series to provide policymakers and educators who are interested in educational matters in nuclear science with information about what is being done internationally and how other K through 12 programs were formulated and executed. The sharing of this information should reveal a portfolio of successful educational programs and options to consider and identify opportunities for learning from each other. The second webinar is really geared towards teachers, administrators, and parents who are interested in nuclear science educational resources, especially in the USA. Today we have experts from the World Nuclear Association and the International Youth Nuclear Conference, and several DOE National Laboratory representatives who will outline the K-12 educational programs at their respective laboratories. Again, thanks to all participants. Future webinars will highlight other K-12 initiatives from around the globe. Collectively, we hope this series will provide policymakers and educators who are interested in nuclear science educational programs with important insights from worldwide experience. And from my perspective as ANS past president, American Nuclear Society is delighted to be a partner in the Nice Future initiative, and in particular in this webinar series. Over the last few years, ANS has worked with Discovery Education and the Department of Energy to develop the Navigating Nuclear program. This exciting new program is developing nuclear science and technology, age-specific educational content to the classrooms, and is in the classrooms of over half the schools in the USA. You'll hear a little bit more about this later. We have asked each speaker to spend about 7 minutes with giving their remarks. And if you have any questions, please use the chat function in the Zoom or in the GoToWebinar part of the screen to post your questions. Thanks again to everyone for joining today. And I now turn it over to my co-moderator, Julia Piscante.
Thank you so much, John. Can everybody hear me? Okay. Hi, everybody. Thank you, John, again. I'm Julia Visconti. In addition to my role at the US DOE, as John mentioned, I'm proud to be a member of the Global Clean Energy Ministerial Nuclear Innovation Clean Energy Future Initiative, known as NICE Future. I want to thank the webinar series co-sponsors, ANS, NICE Future, the SEM C3E initiative, and the International Nuclear Congress, IYNC. Building a network to share proven resources is really more important now than ever in this new academic year with the challenges of COVID-19. Students, parents, and teachers face many new unknowns and unfamiliar learning environments. We face the need for online learning, hybrid approaches, or fully in-person learning with new safety measures. We look toward innovative programs and initiatives that are able to approach education and outreach creatively. Despite these challenges, you will hear how educators continue to provide engaging and meaningful outreach for students to inform and inspire their futures. STEM education and workforce development are a priority for my agency, the US DOE. To develop the workforce of the future, we know we must build a strong foundation through early STEM learning and continue to provide educational experiences and pathways that lead to STEM careers. DOE sees STEM education as a continuum from elementary school to early career and extending to lifelong learning for researchers, educators, and those in the energy workforce. The growing number of nuclear-related STEM jobs need talent. It will take all of us working together to make sure that there are no barriers to access to STEM careers, whether that be gender, race, socioeconomic status, geography, and having a diverse and inclusive STEM workforce is critical to our mission success. I want to mention now the DOE STEM Rising program. Melinda Higgins, one of our speakers, will highlight that. STEM Rising highlights the many STEM programs across the US DOE from kindergarten to the current and future energy workforce. Check out the STEM Rising website. It's at energy.gov/STEM, where you can find information about STEM resources, programs, and events in one spot. We also have a STEM Rising blog to share stories and career profiles, event calendars, active social media presence. You can find all this at the #STEM Rising, at #STEM Rising, and a monthly STEM Rising newsletter to keep up to date on our efforts across the DOE enterprise. So we have speakers from around the world here on this webinar, either in present time or in replay, and wherever we are in the world, we are bound together by common challenges. To put today's discussion on STEM and K through 12 education efforts into a global context, I also want to share with you some quick highlights about Nice Future. I thank Secretary of Energy Rick Perry for his initial visionary idea, and then Deputy Secretary Dan Brouillette and his fellow ministers from Canada and Japan, who in 2018 in Copenhagen led the vision to launch the Nice Future initiative under the Clean Energy Ministerial. We all know that nuclear energy is a workhorse of clean energy, but it took 9 ministerial meetings before nuclear was accepted as a work stream in the SEM and as part of the discussions on accelerating clean energy solutions. The initiative now has engaged 11 participant countries, 15 partner organizations, and has engaged experts from more than 60 countries. Nice Future is open to collaborating with even more countries and organizations. And the Nice Future initiative has 4 focus areas. These range from exploring nuclear innovations to pooling experience, to engaging policymakers, to communication. Of course, our theme of today, workforce development. Our aim is to join together globally with other initiatives to inform, inspire, and build the workforce of the future. Ministers and energy leaders recently were convened by Saudi Arabia at SEM 11 back in September at the SEM Ministerial, a major outcome being the launch of a major report on how nuclear energy can operate flexibly and in harmony with renewables. We invite you to visit the Nice Future website to learn more about the initiative and our exciting work. We're excited today to feature a portfolio of successful education programs for building the STEM nuclear science pipeline. We'll hear international perspectives about the jobs of our future workforce. We'll learn about free digital curriculum tools and navigating nuclear. And we'll learn about programs from US DOE laboratories across the United States that are building a strong, diverse, and inclusive STEM future workforce. So now I will turn with those remarks to our first panel on global leadership perspectives as we all work to build that strong, diverse, and inclusive STEM workforce in nuclear science. I'm delighted to introduce Dr. Sama Bilbao-Leon. Sama is very well known as a leader in the nuclear energy community through her leadership in the OECD Nuclear Energy Agency, where I've had the great pleasure of working with her, earlier at the International Atomic Energy Agency, and earlier as a director of the nuclear engineering program at Virginia Commonwealth University. Today, we are very excited to welcome her freshly in her new capacity as leader of the World Nuclear Association. The floor is yours, Sama.
Thank you so very much, Julia. So I don't know, can the slides be seen, because I don't quite see them. Are they okay?
We can see them. We can see them.
Perfect. Very well, excellent. So let me thank you again for the opportunity to present some of the work that we are doing, trying to help inform and inspire the next generation of nuclear professionals. So I was thinking about the challenge that you posed to me, how to what to present of the work that we are doing. And of course, we all know that there are numerous initiatives at an international level that are trying to reach students and encourage them to pursue careers in nuclear science and engineering. And as you know, and you have presented in previous editions of this webinar, many of them are actually led by national nuclear societies, such as the American Nuclear Society, and then internationally, the French Nuclear Society, the Spanish Nuclear Society, etc. Of course, quite often, these are in partnership with, for example, the Women in Nuclear, which you have also mentioned, and as we will see with the next presenter, with the young members of many of these groups. So what we have seen is quite often the most effective ambassadors that can better reach these young kids are the people that enter the nuclear careers most recently, basically our early career professionals, because they can really relate much better to these younger kids, and they can inspire them, and they can really transmit their enthusiasm for these careers. So this is why at the WNA, we thought that perhaps the best way in which we could contribute to this overall outreach is what we call the World Nuclear University. The World Nuclear University is an initiative in which what we are trying to do is develop the young nuclear professionals into the perfect ambassadors for other outreach programs. Essentially, we are going to take early career professionals and we are going to help them sharpen their communications and leadership skills so they can become the best they can be, the best role models for these young kids that are looking for opportunities to make a difference and to have rewarding careers in a high-tech STEM field. So as I was telling you, the World Nuclear University has quite a few different programs. One of them is the Summer Institute, which is a 6-week program in which we have about 70 professionals for more than 30 countries. And then, as I said, it's for 6 weeks. And we provide them a quite diverse, intensive nuclear leadership course. We go from the traditional project management and communications and leadership, but then we also look into more in-depth aspects of nuclear itself, such as the global settings, the nuclear energy supply and demand, uranium mining, and then we go in things that are maybe not so often discussed in a typical nuclear career, such as nuclear law, the international legal frameworks, safeguards, securities, and things like that. What I think is very important about this Summer Institute is it has created a network of fellows all over the world that they communicate among themselves, they continue to stay in touch, and as I said, they are perfect ambassadors for what we are doing in nuclear and how nuclear careers are exciting, rewarding, and offer the opportunity to make a difference. Let me just also say we have the World Nuclear University short courses. These are very, very short courses, only 2 or 3 days, in which we cover the basics of the state of the art in nuclear. We have done those all over the place. There's been about I think 4,000 people that have gone through these World Nuclear University short courses. Also, we have the World Nuclear University School of Radiation Technology. This is quite hands-on, also a 2-week program aimed at future leaders in the radiation technology area. So this is not only nuclear energy, but this is also medical applications, industrial applications, and many other uses of nuclear radiation. And then finally, let me touch with the Nuclear Olympiad. This is something that is maybe more geared towards university students and even high school students. The idea here is it's an international communication challenge for undergraduate, graduate students, and also high school students. And the opportunity here is to showcase some sort of originality, creativity, and knowledge of the basics of nuclear science and technology in order to enhance the way that we are presenting our technologies to the world. So here you have several cases in which this Olympiad has taken place, and we have engaged with many younger colleagues that hopefully will be engaged in the nuclear sector. With this, Julia, I will stop, and then after the next speaker, I will be happy to take any questions.
Okay, thank you so much, Sama. Perfect. So we'll turn to our next speaker, and Sama, if you could join us in a bit, then we will ask you and our next speaker a question. So I will turn to Christian Vega. He's Vice President of the International Nuclear Congress. Christian is founder and past president of the YNG and also the general co-chair of IYNC Win 2018. I was there. It was a fantastic event. Also, he founded the Young Generation Network in Latin America. He has worked in core neutronic calculations for the Argentinian modular reactor Carem 25 for the National Atomic Energy Commission. He has also worked for EDF in the field of fluid mechanics. And back in Argentina, he worked at the utility Nucleoeléctrica Argentina in accident analysis and thermohydraulic calculations. He now works on licensing activities and safety analysis in the Netherlands. So Christian, the floor is yours.
Okay, thank you very much. Can you, I trust you can all see my screen. And it's a
All
pleasure
good.
to be, okay, thank you. And it's a pleasure to virtually be with you today. During this presentation, I would like to stress out, sorry, I would like to go through why building a strong, diverse, and inclusive STEAM future workforce in nuclear science and application is important. Then I will describe some of our challenges, currently challenge, and what organizations like ICO&C can do towards those challenges. So I think it's well known that 21st century is bringing interesting challenges for us, right? We have climate change induced by human activities and greenhouse effect gases emission. We have the energy demand that is projected to increase twice from 2018 up to 2050. And then we have automatization and artificial intelligence erupting into our economy, which of course is promising to make our economy much more efficient, much more effective, but at the same time, it is promising to build new jobs, mainly related with STEAM areas, many of new jobs, but also will take over low-skilled jobs, mainly in farming and some services. And that is a challenge. In principle, this world challenges brings opportunities for people with capabilities and skills provided by STEAM education, right? And in addition, particularly for nuclear field, because we are for nuclear industry, because we are thinking of a scenario where climate change needs to be controlled, let's say, energy demand will increase, so we need to provide energy with low carbon emissions. Nevertheless, if you see data, sorry, one question. Are you looking at my presentation, right? No presentation mode. All right. I will assume you are.
We're seeing both you and your presentation.
Okay, thank you. Sorry. So if you see the data shows that there's not many people choosing this career path in STEAM's education, right? If you see the graph right here, you will see many countries, and you will see the percentage of students right now that actually goes into STEAM careers, and it's not really very large. The change in countries is not very large, and it's even lowest if you go to other countries or developing world. In addition, you can see in this graph that there is a huge gender imbalance amongst those presuming STEAM education. And why is this important? Why is it important to have a gender balance in STEAM education? Well, I would like to live in a society where individuals can choose the study or career paths that appeal to them without being disencouraged by social perception of what constitutes female or male occupations, right? So I don't have the data, but I can assure you that out of these students, or percentage of students in STEAM careers, it's even lower, those going to nuclear technology, nuclear science, or nuclear applications. And we tried to identify what's the reason for this. And we believe that there's a lack of information or misinformation about nuclear technology in students and population. They may think that this is not a low carbon emission energy source, and also maybe it's not safe. In addition, we believe that the industry is perceived as an old industry and not open to innovation because of many regulations. Also, we feel that there's an uncertainty about the future of nuclear energy. And you can see this in data. After Fukushima, you could see a reduction on students going for nuclear-related masters. And if we talk about Latin American regions, for example, or developing regions, we see that the low access to education is indeed one of the reasons. I would like to stress out why I believe that inclusion and diversity is part of the solution to achieve a clean, reliable future energy systems. And to stress this point out, I would like to talk to you about one of my history, let's say, heroes, which is Nikola Tesla, one of the most brilliant minds of 20th century for sure. And he once wrote to a friend of his in a letter, "My mother was an inventor of the first order and would, I believe, have achieved great things had she not been so remote from modern life and its multifold opportunities." I don't know about you, but if Nikola Tesla is telling me that someone is a great inventor, I would like to hear her ideas, right? But we miss her ideas, in the same way that we miss a lot of ideas along history. Let me show you this in data. In this graph, you will see the evolution of people going to higher education from 1970 to 2010. And this, I am showing the United States as an upper bound because it has always been on the top 3, let's say. And below the 10%, you will see most of the South American countries. And you see that it's constantly, let's say, going beyond 10%, and in some cases, it's actually going down. And the point is that the chances, if you want to find the most brilliant minds and the greatest ideas, the chances are statistically that they will be actually in the upper part of this graph. And these are ideas that we are missing. And I believe that overcoming the challenges that humanity is facing requires knowledge and innovative engineering solutions, so we can achieve a clear and reliable future energy systems. Let me tell you what organizations like I1C can do, but first I will go through our organizations in a nutshell. International Youth Nuclear Congress is a global network of new generation of nuclear professionals whose mission is to communicate the benefits of nuclear science, to promote the peaceful use of nuclear power, provide a platform for networking, and facilitate the knowledge transfer between generations and across boundaries. We are a non-profitable organization that has 46 national representatives, a wide audience around the world, more than 80 volunteers. We have various activities which helps attract, develop, and retain talents in the nuclear field, such as biannual conference, which includes plenary sessions, interactive workshops, technical tracks, and a large variety of tours and networking activities. We are also part of the Nuclear for Climate Initiative and partner with Nice Future Initiative. We regularly cooperate with external organizations such as the IEA, Women in Nuclear, the Rosatom Youth Nuclear Council, and have also other cooperations with the World Nuclear Association and World Nuclear University. But what can IYNC, what's the role of IYNC and young generations around the world? Well, I believe we have the privilege in IYNC to being able to work on the regional basis, but keeping global perspectives. And this allows us to encourage, to motivate, to empower the youth by learning on the job. We can provide young people with the structure and the framework to develop projects and to relate with people all around the world, and to be able to do this in a professional way. Also, we believe that inspiring young is very important through the peer-to-peer experience share that we can actually allow to happen in our conference, that we're bringing together more than 500 participants normally from all over the world. And of course, the knowledge transfer from senior people. In addition, collaboration, because basically IYNC is a network of networks. We work through the young generations around the world by promoting different programs and activities. For example, the mentoring program, where we connect young people with senior people, and this is a program that started in 2018, started the conferences, and now it's being extended by the time between. Also, we have grants, and these grants apply for many things, basically focus on diversity and inclusion, but also for young generations startup in different countries that they don't have yet a young generation. Also, we provide support to best practices and knowledge transfer in this area. And we promote that the young generations share these best practices. For example, the American young generation published a book, which was Marie's Electrical Ventures, that was addressing many of the topics that we are seeing as a problem through the young generations. So I think that's very important. In addition, providing access to information, like generating videos to public, interviews with experts. This is something that many young generations around the world are doing, and we are also starting to do as well. And by finalizing, we also have an innovation for nuclear contest, which is a concept that basically looks for foster new ideas and innovations in the nuclear field. Last presentation, last slides, we've been doing our congress since 2000, and the next one is going to be in Sochi, in Russia, in 2022. So I encourage you to participate, and thank you very much.
Okay, thank you so much, Christian, for those remarks. I'd like to invite Sama to come back into view. Christian, it's very helpful to hear your global perspectives and Latin American experiences, and Sama, your global experiences as well. So I would like to shoot out one two-part question to both of these great speakers from great organizations that are doing a lot in the youth outreach areas. The first is, could you just give us a quick insight about what inspired you on your career path? And then as the second part, taking that inspiration, based on the inspiration you had, what advice do you have for our policymakers and educators that are working very hard with young people around the world to try to inspire them to create effective programs and projects that inclusively develop the essential skills for these jobs of the future. So one is your experience, how you got inspired, and just a piece of advice on how to create effective programs and how to inspire this generation. Any closing thoughts on that?
So maybe I will start this way very quickly. So I will have to say that what inspired me was my mom. I have to say it's kind of like Nikola Tesla. My mom, she was not able to be an engineer for many reasons, but she would have been the perfect engineer. So I always say, and I mean it, when I grow up, I want to be like my mom. So no, I always wanted to be an engineer, and I decided that energy engineering was what I wanted to do. And then, of course, what is the best form of energy? Nuclear. So here we are. And so I really think that a lot of the comments that Christian brought forward are quite important. Is making sure that kids are providing factual information and the opportunity to choose, regardless of who they are, where they live, which sex, which race, which nationality. So I really think that it is important for the policymakers to make sure that the educators have all the factual information that they need in order to actually present that to the students without any without any bias and without any preconceived notions. So I think that would be my very quick message. And if you don't mind, Julia, I will leave very shortly. And I want to thank you very, very much for the opportunity to be here. Christian, a pleasure.
Thank you very much. It's also a pleasure. And well, what inspired me, I must say, and this is basically what got me into engineering in the very first place. It always been fascinating about what humans can do when they work together. And if you look at history, there are several maybe not so happy border conditions in humanity that actually put people to work together. And the accomplishments that happened during those times are amazing. I've always been surprised about that, especially if you compare a picture from 1920 and today's, for example. The amount of technological advance that you will see between these two pictures is astonishing. Most of the people walking the streets in 1920, they didn't even could imagine that actually it would be possible to leave the planet and reach the moon. Now we think this is absolutely routinary, right? Not going to the moon, but maybe having some lunches. So that's what basically motivated me to go to engineering in the first place. And what motivates me today to work in organizations like IYNC, because I really believe that working together and helping, providing proper frameworks for people to do this is a way that we will accomplish astonishing things again. And for the second question, what I believe that maybe policymakers or organizations may take into account, and I will describe something that maybe for some of you is obvious, but it wasn't obvious to me, and it was a lesson learned within IYNC that we are really focusing right now. And this is basically trying to make sure you ask the right questions first, instead of trying to provide right answers. And it seems very logical, right? But it's very common for some organizations to try to provide solutions and programs because they think this is what works and what they need, the population that they are trying to address for whatever reason needs. And we realize that we're doing this in IYNC, and we say, hey, hold on. Why don't we make efforts to try to make sure we're asking the right question first? And then we can see what programs and ideas and activities can actually address the necessities of this population that we are trying to address. So for example, we are launching many projects right now that I will not describe in detail because they're long, but they are basically targeting asking right questions. What is the right young generation actually fighting with right now? What do they think about the future? What's their perception of the future? Perception of the future. What is actually their fears? What do they think that if they have would actually increase their career or potential their career in the future? So we are really working on this, and that's why I believe that is very important for organizations and policymakers to take into account. Make sure they are asking the right questions first.
Good.
I want to thank both of you. Excellent remarks, and we'll make your slides available afterwards to those who are interested. I'm going to turn this over to John Kelly, and once again, thanks to our two speakers.
Thank you.
Thank you very much. Goodbye.
Bye.
Yeah, and I'd like to second my thanks to Sama and Christian. Very, very interesting. Thank you so much for participating today. We next turn to well, it was supposed to be two speakers. Unfortunately, our first one was Janice Lindegard, who had a family emergency. She was going to speak about the Navigating Nuclear program at the American Nuclear Society. And then we also have Melinda Higgins, who is the Nuclear Energy Tribal STEM Advisor at DOE-NE. And her background in STEM education and research segues well with her focus here, which is looking to provide equal opportunity STEM opportunities to students and other underrepresented populations so that they can be aware and open to pursue STEM careers. Melinda will talk about STEM outreach and engagement in the Office of Nuclear Energy and how we leverage partnerships in the STEM space that can be used to listeners around the world. And since Janice is not here today, Melinda is going to cover both topics. So Melinda, thank you, and I'll turn it over to you.
Hi, John. Thank you so much. I really appreciate that. Sending good thoughts with Janice, and I hope everything is going well there. So as John said, I'm a former educator of 22 years and have had a really unique opportunity to support the Office of Nuclear Energy as the Tribal STEM Advisor, as well as working with the office on other STEM initiatives. So really happy to be here today. So as you've heard about Navigating Nuclear, and this is started as a partnership with the American Nuclear Society and with Discovery Education, and they actually partnered to put out middle school resources, including digital lesson plans, STEM project starters, and career profiles before the Department of Energy came in. We were so excited to partner with them to support the high school resources that launched last year, and actually the elementary school resources that just launched during Nuclear Energy Week. And so really excited to begin the journey down in the K through 5, and we'll talk a little bit more about the elementary in just a second. I kind of wanted to talk about the high school resources as well. There is fantastic digital lesson plans, again, in STEM project starters, but there's also a fantastic virtual field trip of Idaho National Laboratory. And we just received the September metrics, and that virtual field trip of Idaho National Laboratory is actually the highest viewed. It has more page views than anything else on Navigating Nuclear this past month. There's also an educator guide that goes along with that, which is really, really great for teachers to engage students and have them learn more about the careers at Idaho National Laboratory, but also the nuclear energy and science of that. Going back to the middle school resources, they actually did a virtual field trip of Palo Verde. And so that's a really cool, that was the second highest page views for educators in September. So again, really fantastic. Our Assistant Secretary, Dr. Rita Barenwall, was just there yesterday. And so we, you know, you're able to visit it as well and through Navigating Nuclear. So the elementary resources, we have a really exciting, what we're doing with them is really exciting. So working with this age group, you have to really make things relevant, well, with all age groups, but certainly with elementary. We want to make sure that, that what we're doing is relevant to their life, something that they can understand and relate to. And so we are looking a lot at the applications of nuclear energy and how that affects students' lives. So not just giving them the nuclear energy basics, which we certainly will. These are the 2 lesson plans that just launched last week. And so there's Amazing Atoms, where students really start to learn a little bit about what an atom is, what are the parts of the atom, and they also kind of take on looking at the superpowers of atoms, as well as looking at how those atoms provide energy. And then exploring energy is the other lesson plan, which is really, really cool. It starts to talk about fossil fuels and wind power and how nuclear power can help support those. So those are available now. We don't quite have the virtual field trip up and ready, but our STEM project starters and our virtual field trips will actually launch as it goes on, as the year goes on. So look forward to more fantastic lessons. This has been such a wonderful opportunity to work with the American Nuclear Society. We all collaborate with Discovery Education about ideas and what's going on and how we can integrate nuclear energy into really applicable lessons for students and for teachers. And so space might be a part of this as well, giving you a little teaser there, which is really exciting. So looking forward to seeing more of those. We also want students to understand that nuclear energy is applicable in different ways and all across the globe. And so if you go into the high school resources, you will see making mosquitoes sit, so the sterile insect technique, and how that helps people around the world with diseases that are caused by that particular mosquito. And so please go on and look at that. You'll also see other resources from the IAEA as well. And NASA has a citizen science called Mosquito Habitat Mapper. So again, that partnership and working together to get that out. As the Tribal STEM Advisor, I also work with our office. Our office has, and the department has tribal working groups. And so we work with them to get STEM opportunities out to the different pueblos and tribes and integrate and work with them and listen. So we've had listening and assessment sessions kind of with all of the tribes in Idaho, New Mexico, and Pacific Northwest that you see on the slide, and really just visit and talk to them and see, what are the things that they have and what are those things that they need, and how we can work together to really integrate traditional ecological knowledge into what students are doing into STEM. The STEM's already there, just how can we integrate and highlight what's going on there. So our office, the Office of Nuclear Energy, also partnered with the Office of Environmental Management. And you'll see these are actually some of the activities from Navigating Nuclear that the students are doing with the adults here. Really exciting learning about energy. And this was during the Nez Perce Tribes PACE camp, so preparing students for academic success. Again, giving them some fundamentals of nuclear energy, but also nuclear energy literacy for everyone, which is really important. Our collaboration partners, so partnering is always very, very important. We work with the Santa Fe Indian School to really bring kind of the community together from New Mexico to look at opportunities that are available. They have an amazing community-based education program with students from all their different pueblos. And we also have, and I'm a part of the team with Talia Martin, we co-lead the 100K and 10 supporting STEM education in tribal communities. So really bringing partners from government, obviously from tribal, but also from industry and from K-12, from research institutes. And we also have a colleague in Alaska to really see how we can come together to work with one another and to help and to see how we can bring those opportunities as much as possible to students. Julia mentioned STEM Rising, and so STEM Rising, actually the link there brings you, she mentioned the blog, and so STEM Rising is a great way to connect with all of the different activities that are going on across the DOE complex. And there's actually a nuclear energy blog that was launched during Nuclear Science Week, and so please visit that. It gives you a lot of different opportunities to engage with our office and the complex on what's going on in terms of nuclear energy. And so that's what I have. Please feel free to contact me if you have any questions or if there's anything I can do to assist. Thank you. Julia? John?
John, you were on mute for a second. John, if you could repeat that, I think you were on mute.
Yeah, thanks. Thanks, Melinda, for covering for Janice, and I hope her family emergency resolves itself. Very interested in this topic, having lived most of my life in New Mexico. I've always been very interested in outreach programs to the many different Indian nations in New Mexico and the whole Western U.S. So thanks for being an integral part of that. But I would like to ask you a question, and maybe you could reflect not only on the answer on your experience, but also perhaps what Janice is saying is what are the major, let's say, challenges or obstacles that you face in basically execution of really good and robust programs, but as you take them out, there's probably some hurdles that you have to overcome. Maybe you could reflect on that. Thank you.
Right, absolutely. So of course, you know, and where we are now, it's very difficult to be, well, we can't be there in person, but we're trying very hard to be there virtually. And so actually we are teaming with different nonprofits as well as different labs. We're working with Los Alamos National Lab and some nonprofits in the New Mexico area, including the museum, Explora and Albuquerque, working to get resources, STEM resources actually in the hands of students. And then we will work with educators in a virtual manner to give them some professional development. It's not the same as being there in person, as you saw from pictures. That's absolutely the best, meeting with education consultants from different areas, as we did with the Shoshone-Bannock tribes, and Jennifer was there as well. And so, you know, that's the best part of it. So that's really, that's a challenge. It's not an impossibility. So working through that virtually, and, you know, the Navigating Nuclear is free, online, standards-based, so really accessible to anyone to go to. So navigatingnuclear.com, you can download it. Parents, I know that we have a lot of teachers that didn't see themselves as teachers and educators a year ago. And so please use these resources. They're fantastic and free and available to everyone.
Well, thank you so much. And again, really appreciate your remarks. It's now my pleasure to introduce Jennifer Jackson. Jennifer is one of the co-organizers of this webinar and is the Idaho National Laboratories K-12 STEM Education Programs Manager. Before coming to the Idaho Lab, she spent 18 years in public education as a teacher, curriculum coordinator, and most recently as the director of curriculum and instruction for one of the largest school districts in the state of Idaho. She leads a STEM education team that includes program administrators, communication specialists, and 7 part-time professional educators. So Jennifer, I'll turn the floor over to you to walk us through the panel session. Thanks, Jennifer.
Thank you, John and Julia, and thank you for having us participate from the Department of Energy Laboratories. For this panel, I'm very excited to welcome my esteemed colleagues who lead education and outreach programs from the Department of Energy Laboratories across the United States. This group loves to collaborate and expand our education community. So we are grateful for the chance to learn from our international colleagues and from each other. We will discuss current challenges, innovative approaches, and lessons learned as we work to build a strong, diverse, and inclusive STEM workforce for the future, even as we all adjust and evolve with new ways of doing things amid COVID-19. Collectively, this panel brings enormous expertise and experience in education and workforce development, and we're happy to share some of the best practices and outreach tools. I'm going to start us out by sharing a workforce development tool developed here at Idaho National Laboratory. This was a collaborative effort between INL, policymakers, and higher education, and it was commissioned by the Leadership in Nuclear Energy Commission, called the LINE Commission, Subcommittee on Education. This commission makes recommendations to the governor on policies and actions to support and enhance long-term viability and mission of Idaho National Laboratory. This interactive digital tool maps education and career pathways to all nuclear-related jobs at INL. At INL, we say that all jobs are STEM jobs. We have the traditional STEM jobs, and a lot of those are represented here. We also have STEM adjacent jobs, so skilled labor, technicians, operators, jobs and positions that are crucial to our mission. And then we also have STEM support jobs, so people that work to support business operations and communications and other areas of the lab. So with this tool, and this actually will help answer a question that one of our panelists had. It's interactive, like I said, and so you can, whatever kind of position or education career pathway you might be interested in, you can click on. So I think we'll go first to the nuclear engineer. Someone asked the kind of salary that a nuclear engineer would make, and this is specific to Idaho, but they do a lot of comparisons, at least nationwide. So for this, we've done a lot of research on job projections for the next 5 years. So we understand what we expect to have as annual openings. We know what the projected job growth will be in that area. And then we figured the median hourly wage. The other thing that is here is what kind of education that students would need to follow to become a nuclear engineer. So from there, it takes them to the different universities within Idaho that they could pursue these nuclear engineering degrees. After that, they can see the jobs that are available within Idaho, and primarily at Idaho National Laboratories and subcontractors. So that was the nuclear engineer, but you can also see things like what I talked about: business operations, production planning, expediting clerks, same thing, the different jobs. So I would encourage you all to explore this. Here's one for a rad tech with the 98 annual openings, and gives you the different education tracks. And I might make note that not all of the education necessary for these jobs are bachelor's degrees and beyond. A lot of these can be found at community colleges or through certification programs locally. So you can find this interactive tool and many other education resources on our website at stem.inl.gov. So now it is my pleasure to introduce our next speaker, Dr. Faith Dukes. She manages the K-12 STEM education programs at Berkeley Lab. Her chemistry background and experiences in science communication, public engagement, and evaluation help to inform the development and implementation of programs for Northern California students. The floor is yours, Faith.
Thanks, Jennifer. Hopefully everyone can see my screen. Right. I'll take that as a yes. So thank you for the invitation to share the work that we've been doing at Lawrence Berkeley National Lab, which is located in Berkeley, California. My name is Faith Dukes, as Jennifer said, and I'm happy to share some of the work we've been doing and to share in this panel and be invited to talk with the rest of my colleagues. Our programs are situated in our Government and Community Relations Office, and we think of ourselves as cultivating the next generation of STEM researchers, professionals, and students that can be supporting STEM innovation in the future.
Faye,
So as I mentioned, yes.
I'm sorry, your screen is not showing at this time, so
Okay.
let's try.
All right.
I don't want you to
So we're
get too
good.
far.
There we go. We'll try it one more time.
There you go.
Oh, we're going to switch it. Sorry. There we go. I think that's it. I'm sorry. If it's not showing.
We saw it for a second. Perfect.
Okay. There we go. Right, thank you. So can we see this shot aerial view? Hopefully you're seeing of Berkeley Lab and above our advanced light source. We were founded in 1931 and one of the first national laboratories, which means we are actually very close to our local community. It only takes a short BART ride and then a shuttle and you can get to our laboratory within 10 minutes, which means we have a really great connection with our local community. We have about 4,000 employees over multiple sites in Oakland, Emeryville, and Walnut Creek, California. That includes postdocs and student researchers, 1,700, which of those are scientists and engineers. And we have unclassified research in 6 scientific areas, which allows us a lot of breadth in terms of the scientific concepts and the careers that we cover. But we also have a grounding in nuclear science and also have been credited with the discovery of many elements on the periodic table. So nuclear science, nuclear engineering, and nuclear medicine are some of the topics that we really focus on as well. We have currently about 150 active volunteers that have helped us do the work for the past 6 months, especially with the impact of COVID-19, as well as us transitioning primarily to 100% virtual programs. And so over the past 6 or so months, we've had about 2,000 volunteer hours and 1,200 program participants in the programs that we've been able to put on all through Zoom or other virtual platforms. And so this has also put us into a mindset of thinking about, our elevator pitches. How do we break down our K through 12 programs? And in that, we're thinking of exciting students between K through 5, letting students explore in 6 through 8, and in 9 through 12, making sure they have experiences in STEM opportunities. And so you'll see that broken down a little bit more here, where we're thinking pre-K through 5th grade. We are working with our organizations in our community that are already doing wonderful work. We know that when we even go back into in-person opportunities and outreach, we typically cannot have K through 5 students on site. So what we want to do is build relationships with the organizations that are already doing wonderful work and have connections and are in elementary schools, and provide them with either scientists that can talk to classes, or just recently we put together about 400 kits for an organization that was hosting online opportunities for K through 5th grade students. So our scientists and administrators and support staff were able to do that work. The next step in 6th through 8th grade, we are thinking about our classroom visits. So we've launched a program called Let's Talk About Science, where some of our scientists are going in and either talking about a scientific concept, or they're talking about their work as their career. We also have Explorations in STEM through a live science show that we've developed where we work with a scientist over a month to develop a 1 hour presentation and a webinar that also allows people to ask questions in real time that talks about their research, but also gives them an activity at home that they can take part in with us. And we're continuing to support events in the community, and eventually we'll have some competitions that we want middle school students to take part in. And in 9th through 12th grade, we know this is where our strength is. So we are also doing classroom and site visits with those students when we get back in person. But right now we're doing a lot of career talks in the classroom through Zoom. We are starting to think about what short courses we can put together. We are currently hosting public career talks every other Friday. And this summer we were able to host a pre-internship program for about 4 weeks. We know that we also want to equip these students with the tool sets they need, but also the knowledge they need in order to prepare for DOE-funded opportunities as undergraduate or graduate students. And then finally, we want to make more connections to our STEM educators that are in our area. So we are preparing STEM resources. We're making sure that we connect standards to some of those webinars that we put together. We're also thinking about the professional development that we can do. We've connected with other organizations to make sure that some teachers are able to either get experiences at the laboratories or research, or just have a walkthrough of the laboratory to understand what's being offered if they were to bring their students on site. And finally, I'm just going to show you a look at what I've just talked about in words. So you'll see top left-hand corner, our live science series is that monthly session that we have with our scientists that have covered everything from starting a yeast starter, but also talking about the genome of yeast, to sustainability and soil science with our environmental and earth science engineers, but also talking about how to start your own compost at home, and working with our Lawrence Hall of Science neighbors. We collaborated on an astrophysics themed session where we went through looking at and identifying stars. And you can also see the Let's Talk About STEM series, the apprenticeship program, and our career talks that we've been continually having since summertime. And our SAGE program, which we've partnered with Slack National Laboratory, which hosted nearly 100 girls online for a week for job shadowing, career talks, in-person hands-on activities that we did online, and other opportunities that we had in order to engage them in thinking about STEM careers. And so that's a really quick overview of what we've done at Berkeley Lab, thinking about cultivating the next generation and exciting, exploring, and experiencing different ways in which we can engage students in STEM. And so if you want to know more about what we're doing, we have k12education.ldl.gov for our website, and we are also on Twitter at LBNL Next. So thank you for the opportunity to share, Jennifer.
Thank you, Faith. And I would encourage everyone to follow them on Twitter. They have a great Twitter feed, lots of quality stuff. So thank you, Faith. And we now turn our attention to Tom Mason at National Renewable Energy Lab. Tom has been counseling and teaching students of all ages for more than 20 years. His primary focus has been on introducing underserved students to STEM opportunities and available pathways by involving them in hands-on projects with real-world applications. Tom designs and develops education and outreach programs intended to pull back the curtain on complex science concepts to reveal to students how they can observe similar concepts in their everyday lives. Tom, my question to you is, how does NREL engage diverse K-12 audiences in programs that demonstrate STEM career pathways?
Good question. Thanks, Jen. Thanks for the introduction. Are you seeing my screen?
Yes.
And you can hear me okay, obviously. Great. Well, thank you. And I appreciate the opportunity to be here with you all. And I'll get to that question in just a minute. As Jen said, my name's Tom Mason. I'm the Education and Outreach Program Coordinator at the National Renewable Energy Laboratory. The mission of NREL is to advance, let me go back one slide. It's to advance the science and engineering. Sorry, I've lost my screen here. There we go. So the mission of the National Renewable Energy Lab is to advance the science and engineering of energy efficiency, sustainable transportation, and renewable power technologies, and to provide the knowledge to integrate and optimize energy system. So of all of the 17 Department of Energy national laboratories, NREL is the only laboratory that focuses solely on renewable energy and energy efficiency technologies. You can see our campus, our main campus, which is called the South Table Mountain campus, which is in Golden, Colorado. We also have facilities in up the road towards Boulder, which is our National Wind Technology Center. And then we have a facility in Washington, D.C. and one in Alaska as well. So as far as the K-12 STEM education programs go, traditionally we would be on campus here in the very bottom of that picture. There's sort of a tan colored pink walls building there. That's our education center. So we're actually located just outside of the security gate for the campus, which is convenient for us because we do traditionally bring students onto campus and have programs for them at the education center. Whereas we're not necessarily always able to bring students into our laboratories, but we can deliver them programs in close proximity to our laboratory facilities. But our main vision is to spark the interest and curiosity of students, families, teachers, and communities in STEM through engaging experiences driven by our research and development. As many of the speakers from the national labs may talk about today, we also rely heavily on volunteers. My colleague Megan and I deliver most of the programs. We have one full-time assistant supporting our programs, but we do rely heavily on volunteers, including from our scientists and engineers. At NREL, we have about 2,500 employees, and about 65% of those are scientists and engineers. About half of those folks have their PhDs, and then the other half is split between bachelor's and master's degrees as well. But what I want to focus on today, and what Jen's question gets at, is how are we recruiting diverse audiences to our programs and ensuring that we are serving students who need our programs, underrepresented in the STEM fields. And today, especially in a virtual environment, we've talked about a little bit, or heard a little bit about how to be creative in developing our programs to meet the needs of today's audiences. So one way we're doing that, I'll start with the youngest students. We have developed, starting back in the late spring, transitioning to virtual programming with our K through third grade audiences. So these are 5 through 8-year-olds with a weekly story time session. We're actually doing these twice a week now. We recruit NREL staff, so these might be scientists and researchers, or it might be Megan or myself, our education staff, reading stories, everything from Ada Twist scientist and Rosie Revere engineer, things like that, to things more specific like Solar City, which focuses on solar, renewable energy, and wind technologies, things like that. So books that are relevant to the research that we're doing at NREL, but that are engaging and that show students from non-traditional STEM audiences, give them some inspiration to look to their future and what kind of pathways might be available to them. And then we usually finish reading the story. The scientist or engineer or STEM support staff who join us talk a little bit about their career and their pathway to NREL and working at a national lab. And those are held on Mondays at 1:30 p.m. Mountain Time and Thursdays at 10:30 a.m. Mountain Time. And you can find more information at the website there, nrel.gov. So moving on to our sort of our middle school, late elementary school program. What we've done here, this was our the bulk of our programs. We would have about 2,000 students come to campus each year for a field trip. And we've actually found that in the virtual environment, We've been able to expand our audience out to some audiences that we have not traditionally been able to serve, which has been one nice thing about being in a virtual environment. But this is a weekly experiment series we have. Megan and I will present 4-part experiments, so 4 days a week, Monday through Thursday. The first session is on the grid. We also have a solar detective program put together. We have a program that will focus on biomass and one that will focus on other renewable sources of generating electricity. So we have 4 of these programs and we rotate them through about every 5 weeks for the students in this age range. So those are 9:30 a.m. And we have about 20 kits that we're just starting to distribute. We provide all of the materials that teachers and students would need for up to 30 students at a time. The only things we don't provide are consumables like the potato you see here or other types of biomass and things like that. And then finally, our high school program that we are currently developing for virtual programming. It's called our High School Summits. This is an exciting program that, again, we are recruiting students from underrepresented audiences through our community partnerships to join us in solving real research problems that are going on today. Our first program will be based around the phenomenon of plastics in the environment and whether or not students see it as a problem. So kind of what's the problem with plastics? Just give them a real basic question that's culturally relevant to them. And that's something we've done is aligned all of our research areas with how do those research areas apply to these students that we're recruiting in their communities and in their everyday lives. And so what we do is Megan and I are responsible with our communications folks for translating some of the publications, the scientific publications, into a plain language synopsis. We give those to the students. They do some research for about 3 weeks. They'll join us in an online virtual video conference and work alongside with their peers from other schools with NREL researchers to design and develop potential solutions to those issues. And then some other K-12 STEM programs at NREL that we've traditionally been involved in. We are the Colorado Regional Coordinator for the High School Science Bowl. We also have a middle school car competition each spring with battery and solar powered cars. We do a lot of ad hoc, sort of on request community outreach programs with groups, a lot of groups that deliver programs specifically to girls, young women in our community, such as Junior Achievement, Women's Wilderness, and Girls Inc. We have a teacher professional development program that we are currently in the process of transitioning to a virtual environment as well, called the Energy Institute. And then I've been doing some benchmarking with some of my colleagues to develop a high school research program to actually bring high school students onto campus at NREL. And that's all I had for everyone today. Again, I appreciate the opportunity to be here. Thanks, Jen.
Thank you, Tom, for that glimpse into all the great work that you're doing. We'll head now to Chicago and introduce Meredith Brocious. Meredith leads the education department at Argonne National Laboratory. She brings over 20 years of experience across the formal and informal STEM education spaces and has deep expertise in designing innovative and engaging learning experiences that inspire students to pursue a career in STEM. What would you like to share with us, Meredith?
I guess I am sharing my screen.
Meredith, we can hear you and we see there you are. Now we see you too.
Okay, cool. Thank you. Well, thanks for inviting and having us. It's always great to connect and be on a panel with both Faith and Tom, and you'll soon meet our fourth presenter. And I would just like to tell all those educators out there that we are with you and we're here to support you as best that we can, and we recognize maybe some of the struggles that that you're having. And so please do reach out to us at the National Lab Complex as ways to support, because we've been trying to build programs for that purpose. So Argonne National Lab is situated right outside of Chicago, Illinois. So I feel like we're moving across the country. We started in California, we made a stop in Colorado, we're now in Illinois. And like many of the other speakers on the call, there we go. We are a DOE National Lab that has about 3,500 employees, of which half of them are individuals doing R&D research and at the PhD level, and the other half are in support, or I love the term adjacent roles to STEM. We do have nuclear energy as part of our portfolio of programs. It kind of crosses over some of our major initiatives, which I have highlighted on the screen right now. And one of the other big key spaces that Argonne is known for is computing. So we have one of the fastest supercomputers in the world, and we'll soon be having an exascale computing coming in a couple of years. So computing and how computation fits into STEM is a big area for us at Argonne. And so I share the slide to give you the idea of the breadth and kind of things that are going on within Argonne and DOE. And really want to talk about, before I get into the details of the programs, the notion that students start out, when you talk to somebody who starts out in a nuclear engineering space, or a nuclear chemistry space, or a radio technician space, or anything that kind of fits in that nuclear space, they started just kind of exploring about their world. They started just in general STEM programs. So as you're trying to make a connection to the conversations that we're having and the things that we're talking about, keep in mind that when you're in third grade or fifth grade, or even in high school, you're still just kind of exploring all fields of STEM, and you kind of stumble into and see opportunities in nuclear, and then kind of firm up your path as you get a little older. So as we talk about these activities, it does help support generating the next generation of nuclear professionals. So specifically at Argonne, I guess it wants to. There we go. We see our work similar to how everybody else has kind of talked about it, based on kind of students at different age groups. Our focus is really being that connector to today's world-class research that happens at Argonne and within the DOE complex, to tomorrow's leaders in STEM, to tomorrow's problem solvers in STEM, people who will be tackling or continue tackling the problems we don't know about, or the problems that we're still trying to solve right now. And so we really see our audiences as youth and family. We have activities that are focused in middle school space, high school, undergrad, and grad, and we look at it as a pipeline, and we're looking at programs that can connect and keep kids sustained in this pipeline. One of the things for us that connects this pipeline is this idea of science identity. So as students do scientific experiences, or have STEM participate in STEM programming, or they themselves are practicing kind of STEM-like skills, they build a confidence in themselves to see themselves as being someone who belongs in the STEM world. And so all of our programming is kind of centered around the building confidence, knowledge, and championing students to help build their STEM identity. We see roughly over 30,000 students through our programs, kind of broken down in our different groups. So our youth and family programs tend to be very programs that go out into the community, connect in various things that the community is doing, bring our resources out, help bring scientists out to those spaces. We have an on-site learning center, of which we see, well, pre-COVID saw 3,400 students through that in field trip based programs, camps, things of that nature, where they come on and do. It tends to be middle school and high school students. And then we've all alluded to, and I know this is a K-12 panel, we've alluded to this idea of internships and university students. That's because we're building a very large pipeline for then students to take that next step and start to put their toe in water in research experiences. We do this as in a way of being strategic, collaborative, and mission focused. So when we can connect that national energy with a laboratory strategic initiative and this notion of the student building a space and an identity for themselves in STEM, that's kind of our sweet spot right there here at Argonne. We create things called career pathways, and computing is an area that we see is a barrier for many students, particularly students that are underrepresented. And it doesn't necessarily mean that this is connected to specific just to computing, because I know there's a lot of conversation around computational thinking and computing happening in spaces that are just for the sake of computer science. We actually see computing similar to how math is also considered a barrier in the STEM pipeline. We see computing as being a skill, a knowledge, a capacity for anyone in any STEM career that they're going to have to know as we start to move in or have moved into this field of big data. Scientists are pulling data, have huge, cool tools that take data very quickly, which give them big data sets, which now means as a scientist in nuclear, in chemistry, in material science, that you're going to have to be able to understand how to manage and manipulate that data or predict from that data or model something from that data. So computing is a skill set that we really feel is something that we should be focusing on. And what we do is when we teach computing, we teach it in service of science. So the projects and activities that students are doing are specific to a scientific area. So in our outreach space, we visit classrooms. Right now we have something called Argonne Live. You could participate, I believe it's 2 days a week, where you could go on and different topics that are happening and connect with 2 or 3 scientists and a grad student on a particular area in science. I know we've done one on nuclear research and kind of the portfolio of nuclear research geared towards a middle school, high school audience. We've taken all of our competitions virtual. We'll be launching a brand new nationwide virtual competition probably right after the holidays, and have hundreds of volunteers that are looking to do things in classrooms. So I just ask that if you're interested in having scientists visit or connect with you, please let us know, because we have people who are interested in doing that with you. At our Learning Center, as mentioned, all of our programming went virtual, similar to how some of you in our teaching community has felt. So we've taken all of our camps virtual. We've taken our high school research program virtual, and we're working on creating a hackathon-like program to be launched next spring in a virtual way, where we would have kids work in groups around a particular scientific problem and using data. And then in the university space, these are lots of different ways in which students come into our program. So I just want to show you the back end of the pipeline, as we're talking about kind of the early part of the pipeline here. If you're interested in any of these kinds of things, I just ask you to go to anl.gov/education. We have a listserv that you can join, and that pretty much gets some announcement at least once a month. We send out a monthly newsletter. We also on our website have our newsletters backlogged, and so in October we did focus on nuclear energy, and there is a hands-on activity, a chat with a scientist, and an article that's written at a 8th grade reading level that you could use in your classroom. Argonne Lives are all recorded, and I believe there is one that was done on nuclear research that you can go back and look at. And then if you join our listserv, you'll be aware of our virtual competition, because we'll be pushing it out through those that have joined the listserv. So feel free to connect with us. If you have any questions, please reach out. We're happy to assist.
All right. Thank you for that showcase of what's working from Argonne National Laboratory, Meredith. Now we'll turn our attention to Oak Ridge, Tennessee, to hear from Allison Melton. Allison is the Education Outreach Specialist at Oak Ridge National Laboratory. Prior to working at ORNL, she worked as a science educator in both formal and informal education settings. Take it away, Allison.
All right, hi. Thank you for this opportunity to share our work at ORNL. Can you see my screen?
Yes.
Wonderful. Okay, so my name is Allison Melton. I'm the outreach specialist, education outreach specialist at Oak Ridge National Lab in Oak Ridge, Tennessee. I'm going to share a little bit of what we are doing in our kindergarten through 12th grade education outreach space. So ORNL is the largest by size of the DOE national laboratories. It was established in 1943 as part of the Manhattan Project, and we've continued to build on our legacy of discovery and innovation. We have 6 main areas of research at Oak Ridge National Lab: neutron science, high performing computing, advanced materials, nuclear science and engineering, and isotope science. It's the home to over 5,000 employees, the world's most intense neutron source, the nation's most diverse energy portfolio, and one of the world's fastest supercomputers, and a world-class research reactor. So we have a really unique space in our area because there's nothing else like it around us. Our flagship outreach effort for kindergarten through 12th grade students is the Traveling Science Fair. The Traveling Science Fair consists of 6 of these mobile exhibits, and you can see what they look like in that picture there. Those 6 mobile exhibits are aligned with our 6 main areas of research. They're staffed by scientists and professionals. We have one for supporting research, which is not scientists, but professionals who help support our mission. And these mobile exhibits offer opportunities for students to hands-on activities relating to our areas of research and meet with real scientists. And for a lot of the students areas that we go to, we try to take these to rural areas and urban areas. And for a lot of those students, it's their first opportunity to really meet a scientist and see what a scientist looks like, find out what the day in the life of a scientist would be like. So it's a really unique opportunity to share our work. We take those throughout the Southeast pre-COVID. Now we're working on a virtual option so we can allow students all over the world to access these virtually, but that is still in the works. On site, we do facility tours for middle school and high school students. In a typical year before COVID, over 100 of these tours would come to our facilities per year, and we take them to sites on site that coordinate with what they're studying in school. This moved to a virtual platform in 2020, and we've worked really hard to get a really immersive virtual tours in place, and you can access those at map.ornl.org. And those are available for anybody that wants to view them. We've had school groups use them, community groups use them, individuals use them to see what's going on at Oak Ridge National Lab and what our facilities look like, which is really neat. Offsite, we do STEM nights at local schools and with community organizations, career fairs throughout the community. Those have moved to a virtual platform, so we've been doing virtual community or virtual career fairs for groups throughout the area. We do competitions like First Robotics and Science Bowl, where our staff works as mentors and helps facilitate these competitions, and we rely on volunteers from our employee base for that. We do things like Hour of Code and National Engineers Week, where scientists go into the schools and work with the students on coding or engineering projects and share their work. Those will be moved to an online platform this year. So this will be our first year doing them virtually. The move to the virtual space has really allowed us to reach groups that we typically wouldn't. So we were able to meet with groups, connect groups with our scientists from a national and international in an international way that we have not been able to before. So we were able to connect with new groups that we've never had exposure to before, which is pretty neat. We have a variety of high school internships for students that are in high school and have just graduated from high school, and even one for middle school. The first one, the Appalachian Regional Commission Summer Math Science Technology Institute, is an opportunity for middle school or high school students in teams with a teacher to come to the lab during the summer, work with a researcher on a research project, which is really a great opportunity. Those are for any student group that's in any of the 13 Appalachian states. And a lot of those are kids from really rural areas, so it's a really great opportunity for them. We have a high school research experience that allows students to come into the lab and do research with scientists for school credit. We have a higher education research experience for entering freshmen for students who have just finished high school that comes with a stipend, laboratory tech internship program, and the Next Generation STEM internship, which is for any high school student in the counties where our employees live, with the 5 counties our employees live. Some of these have moved to an online platform because our in-person internships are paused at the moment, but there's still the opportunity. And sorry, that went really fast. You can find additional resources at stem.ornl.gov. We update that website with new opportunities as we develop them. There's an opportunity there to sign up for virtual sessions with scientists to speak with your classroom, or to do a virtual tour that's led by an employee here. You can also get a hold of me at meltonam@ornl.gov or stem@ornl.gov. And that's all I have.
Thank you very much, Allison. Our next speaker is Evangelina Galvan-Shreve, the Director of STEM Education at Pacific Northwest National Laboratory. Evangelina has more than 25 years of experience in policy and public administration for K-20 education and STEM education initiatives. She is a leader in STEM equity and inclusion efforts for those populations that are underrepresented and underserved in STEM. Evangelina will provide a high-level overview of PNNL in Washington State and discuss the strategic signature STEM education efforts and initiatives relative to STEM outreach and workforce development. Take it away, Evangelina.
Thank you, Jennifer. I will try to make up the time here. I know we're running late. Can you see my screen yet?
No. We saw it a second ago.
I know, I don't know what happened. Give me just a moment here. There.
Perfect.
Okay, great. So you can see it now.
Yes.
So I'll just go fairly quickly, just a little bit about Pacific Northwest National Laboratory. We're very unique because we have 4 sites in our state. The main campus is located adjacent to the Hanford Nuclear Site. We have the only marine science lab in the National Laboratory System located in Sequim. And we also have an office in Seattle, which is located in the Innovation Hub in Western Washington, which is adjacent to Facebook, Amazon, and Microsoft, a very unique corner of the Seattle area. PNNL has great value in Washington State. It has many collaborations and partnerships here, and we provide support to very interesting, challenging national problems, and we help address some of the Pacific Northwest challenges as well. We are one of the largest employers in Central and Eastern Washington, the desert side of Washington State. We have about 5,000 employees as well. One of the unique things about Pacific Northwest National Laboratory is that we have been managed by the same organization for 50+ years, Battelle Memorial Institute. We are unique because the investment in STEM education is built on the foundation of the Gordon Battelle will, which is committed to education and diversity. So we feel very fortunate that we really have a culture of, especially with our scientists, to really get engaged in STEM education. And like my other colleagues, our STEM education efforts are really built on the sense of volunteerism and being concerned for who's going to be our future STEM workforce. Some of the outcomes that we strive for, and like my colleagues, is that really having an understanding that every career is a STEM career. And so we really spend our time ensuring that we're helping increase STEM literacy. We are very focused in underserved and underrepresented communities and targeting our work to the greater population. We are doing this, much like everybody has said today, in developing that pipeline towards that future STEM workforce, in particular for the Department of Energy. We do this through a variety of partnerships, as I've mentioned, and also ensuring that students really engage where disciplines converge. So really understanding that integrated science approach. Much like Meredith mentioned, we believe computational literacy and STEM capability are foundational across all our effort. We have 5 signature areas, and I'll spend most of my time focusing on the K-12 efforts that this audience is interested in. But our 5 signature areas are represented in STEM outreach, STEM equity inclusion, and professional development for educators, computing science education, and our focus on the DOE workforce and the development of that. In the area of STEM outreach, I would say our signature program that really impacts especially the K-12 audience is our program called the STEM Ambassadors. This is where P&L scientists and engineers who share the wonders of science and their research with students, teachers, and the general public through community talks or school engagements. They use interactive hands-on displays that are reflective of the real science that's happening at the laboratory, and provide an experience for students and educators that help them understand the science that's happening, and with the goal of inspiring and gaining awareness of the careers that are available for them in their future. We have over 110 STEM ambassadors at PNNL, with over 110 different science being portrayed in the displays. So we feel really good about that program. Like my colleagues, the last 7 months, we've been working to pivot that program to be virtual and be offered through remote ways. So this summer, we launched our first Instagram TV, and we had over 100,000 views with our STEM ambassadors. So we're continuing to try to build that to reach the audiences and help educators bring some of those resources into the classroom. As I mentioned, we are very purposeful in having a STEM equity and inclusion signature effort. And one of our main programs and collaborations that we're very proud of is working with the Washington State MESA program. MESA, for those of you who may not be familiar, targets underrepresented students from 6th to 12th grade and from undergraduate as well at the community college level. Our program, in collaboration with the University of Washington and the MESA program, the Math, Engineering, Science Achievement Program, is in the southeastern part of the state. We help lead that effort on behalf of the University of Washington, and we serve over 500 underrepresented, underserved students. And essentially, we take them through, with volunteers, through experiences that eventually lead them to an engineering design challenge. Prior to the lab becoming engaged on the MESA program, it was always the Western Washington groups who would win that competition. I'm proud to say the last 2 years, our very diverse students have been the Washington State winners of the MESA Engineering Design Challenge. In the area of professional development, we have a very unique program in collaboration with several partners in the state of Washington. It is a 1-week teacher institute where then teachers get an opportunity to work next to national laboratory scientists, working on a particular science challenge and going through that scenario and learning how they take what they're learning and apply it back in the classroom. We're really proud of that program. It's been something that has focused on different science challenges, and we have teachers often wanting to come back for that experience again. So we're continuing to focus and try to develop that program. This summer, we held 3 one-week institutes, and all the teacher cohorts did their work virtually, and it worked quite well. As Meredith said, we have quite a focus on computing science education, and I In the K-12 space, we're working with our local universities to really develop a curriculum that can be offered in continuing education credits to K-12 teachers to provide them more foundational knowledge that they can apply in the classroom. Like Meredith and Argonne, we participate in several competitions. In fact, one that is led by my colleague in Argonne and other national laboratories, the Cyberforce competition, which we're quite proud of. In the DOE workforce development space, we also have about 1,200 student interns that we support and provide placements for annually. We're very proud that this summer we were able to retain, through pivoting those internships, over 900 interns in a remote setting to complete their internship. We have a smaller program for high school students, but we are trying to build that. Currently, we host about 50 high school student interns in that space. One of the things that we do that's unique in the workforce development area is offer what we call the P&L Gold experience, which is really focused on developing enrichment activities that helps the interns understand what happens in the Department of Energy complex, the opportunities and the career pathways that are available there, and how to develop their professional network and knowledge, ensuring that they stay in a STEM career pathway. I mentioned that our experiential and career connected learning and several of our signature programs there. I would just note that I don't have my my website listed here, but if you go to the Pacific Northwest National Laboratory to STEM Education, you can learn more about the resources that we have available to you. Like my colleagues, we are trying to be more purposeful about offering online tours and opportunities to meet STEM ambassadors, and making that accessible to everybody across the nation and the world. Thank you, Jennifer.
Thank you, Evangelina. And I want to thank all of our panelists for contributing to this great discussion about STEM education and building that STEM pipeline needed for the future. We know this work of inspiring a future workforce is essential to the success of our energy future. As a panel representing STEM education at DOE Laboratories, we are honored to be included in this webinar. We appreciate the opportunity to highlight this important work. John, I now turn it back to you for closing thoughts.
Okay, thank you, Jennifer. Again, I wanted to thank everyone for participating, and as a reminder, if you're interested in the Navigating Nuclear tools that are available, they're available at the American Nuclear Society website, which is www.ans.org. And again, thanks everyone, and I want to turn it over to Julia Bisconti for the final words. Julia?
Okay, thanks, John. Thanks, everybody, for what has been a really amazing discussion. I don't think we've ever seen this collective of experts from DOE National Labs focusing on education together in one place. Truly amazing ideas, and also amazing opportunities that were laid out by our presenters. So thank you to our panelists. Thank you to Eric Schuster for running this platform today. Thank you, Jennifer, as well, for your efforts. And we thank you, our viewers, for this stimulating discussion. And we will be posting this webinar on the Nice Future website for replay, but we are doing a rebroadcast, a full rebroadcast on Saturday, November 7th. And we will be doing other webinars in this series. So please look for our future webinars on the Nice Future website, which is at https://www.nice-future.org. Again, thank you so much, everybody, and we appreciate these great discussions and look forward to more of them. Thanks, everybody, and goodbye.